Good morning, friends. I hope you are good and you are doing well in subject. So today our goal is to solve one of the JEE mains problem on the concept of Newton law of cooling. There is two methods are there to solve this problem. One is the shortcut method, another one is the somewhat long procedure. Mainly I am concentrating on doing the two methods. So before dealing the direct solve the problem, we need to know the perfect concept, what is meant by Newton law of cooling. That is our goal. So today our goal is to learn about the Newton law of cooling complete and to solve the depending upon the problems which recently which we asked which they are asked in the JEE mains exam, that is the 2021 and 2020 the two problems we will going to solve. So if build up the concept, you can easily go through the remaining problems. So let me start without wasting our valuable time. What is the now let me start the Newton law of cooling. Newton's law of cooling. So what is the basic observation done by the Newton's Sir Isaac Newton's means let me take one of the hot body. We are taking here is the one of the hot body. Let me take this is the hot body. So this hot body is in surrounding, the surrounding also having some temperature. So what is the temperature of the surrounding means let me take T naught. T naught is the surrounding temperature. The hot body is having at a temperature of T. So that means the temperature of the hot body is greater than to the temperature of the surrounding. Then we will observe that due to the temperature difference between the hot body and surrounding, if there is a temperature difference, then the hot heat will flow from higher temperature of the body to lower temperature of the body. Here higher temperature of the body is the hot body, the lower temperature of the body is equal to surrounding. Surroundings are there. Here the surrounding is there. So that heat will flow from the higher temperature of the body to lower temperature of the surrounding. So when the heat is flowing from higher temperature of the body to another lower temperature of the body, then there must be temperature drop in the hot body. That means the temperature will going to be decreases for if the time is passes. That is the observation what we done in your daily life. That means how much the temperature is decreasing with respect to the time, and what is the dependence parameter in the surrounding temperature. That is that Newton is given one of the theoretical explanation, and also he will derive the one of the mathematical equation to find out the what is the temperature of the body at a particular time. That means if we take to solve, to approach this concept, what he assumed, that means the temperature difference between the hot body and surrounding is very small, then only we will go through this concept. That means the T minus T naught is a small value. That means then only we can then only we will go to the we can solve the problem easily. Then only we will apply this concept. If there is a much difference between the hot body temperature and surrounding temperature, we are unable to use this concept. So what he assumed means the rate of cooling of the hot body is directly proportional to the temperature difference between the hot body and cold hot body and surrounding. So that means the rate of cooling of the hot body is directly proportional to the temperature difference between hot body and surroundings. That means to drop the temperature of the hot body, it is the temperature is decreasing. That value is directly proportional to the the temperature difference between the hot body and temperature. Let me assume we are observing the hot body temperature at instant. So while we are doing the experiment, that particular time the hot body temperature is assumed that hot body temperature is the T. The surrounding temperature is T naught. Please keep it in your mind. The hot body will not changes the temperature of the surrounding, because of there is a temperature difference and hot body temperature is a very small value. Then only we will approach this concept. That means at a given incident the temperature of the hot body is having the temperature of T. So at a incident or we are taking that at a given time, the temperature of the hot body, is assumed as capital T. So then we are assuming that the temperature of the hot body is capital T at particular time. Then the rate of cooling of the hot body is directly proportional to the temperature difference between the hot body and the surrounding. That means it is cooling down. That means the rate of cooling, it is the variation of the temperature delta d theta by dt is directly proportional to the temperature difference of the hot body and cold body T minus T naught. So it is a decreasing. We are indicating this negative sign here. It is the just mathematical expression of the above sentence. This is this sentence mathematical expression we are written here. That means here this is the rate of decreasing. So it is cooling down means negative sign we are indicating. The rate of cooling of the hot body is directly proportional to the temperature difference between the hot body and cold body. Now let me go to the another board. So that means what we drawn in last concept means minus dt divided by small dt is directly proportional to T minus T naught. This is the formula we approached. Now let me take let me take here. So if we remove the proportionality constant, we need to keep one proportionality constant k into T minus T naught. Here k is the proportionality constant. It will depends on the thermal conductivity of the material. K is a proportionality constant. It depends k depends on thermal conductivity of the hot body. So it depends on thermal conductivity of the hot body. So it is a proportionality constant. So they will provide this proportionality constant to solve the problems. So now if we are assuming that this rate of cooling of the is a one particular parameter, let me take it is a rate of cooling is there now. Let me take that is a C, constant is a C, rate of cooling. If we are assuming that minus dt by dt is equal to C, so that is equal to, then so will you please observe this one, that is equal to k into T minus k into T naught. If you multiply this k so k into T naught and k minus T naught we will observe, that is equal to C is equal to, we are assuming that let like this, then C is equal to what we assume, let me take C. Okay, C is equal to y is equal to mx plus c will come. Better to take like a b, rate of cooling. Let me take capital R, no issue, rate of cooling capital R. So R is equal to K into KT minus KT naught, we will get this. This is the equation. Now use your please think yourself. I already told you T naught is the surrounding temperature, it is always constant. K is the some constant is the depends on thermal conductivity of the material, it is also constant. So this parameter is a constant term because of T naught and K is the both are constant, that is this parameter is the constant term. So here is the constant term is there, but the temperature of the hot body is always it is going to be decreases because of if the time is going on. So that means here R is the rate of cooling, it is also it is a variable parameter. Now if we assume this one y is equal to, it is the one of the variable. So here is the one of the variable, I am taking m, here is the another variable, sorry, it is the constant term m, t is the variable mx minus we are getting some let me take plus c, this is the formula, y is equal to mx plus c, this is the formula we are getting. That means if you draw a graph on while taking the y value, the y coordinate value in the rate of cooling value, and x coordinate value, the temperature of the hot body for every instant, then how the graph will look like? It is straight line which is having with a slope of m, that slope of m is equal to k value. Let me draw the graph how it look like. So this is the graph which we are drawing. So the y value is taking the R is equal to rate of cooling, cooling, this is the rate of cooling value, y value we are taking. So what is that, what is the x value we are taking? T, temperature of the hot body, temperature of the hot body we are taking on x axis. Now how the graph will look like? It is not passing through the origin because of it is having c value, so that's why it is making some positive slope. So that means what is this graph? This graph is equal to mx plus c kt minus k into t naught. So if you extrapolate of this graph, it will intersect on the y coordinate. That y coordinate will give the c value. What is that c value? Is equal to the magnitude of this magnitude of the intersecting point from the origin will provide the value of the k into t naught. So this graph will provide the slope value will provide the information of this the k value of the material, that k will provide the slope of the graph. The magnitude of the slope is equal to, that is equal to slope of the graph from this one. So we we understanding that if you draw a graph for the rate of cooling and the temperature of the hot body, it is a straight line which is having the positive slope. If the intersecting point of this straight line on the negative coordinate of the y axis, then it will provide the k into t naught of the magnitude. From this information we can extract the what is the parameter of the constant parameter of the material k. If you know that T naught is the surrounding temperature of the hot body, and also the slope of the graph will have the it will provide the information of the material constant of the proportionality constant of this equation, k is equal to, which depends on the thermal conductivity of the material. Now if we go to the direct approach for this one, what this equation I am taking once again, minus dt divided by dt is equal to k into t minus t naught. This is the formula we are having. Now will you please look on this one. Our goal is to find out the what is the temperature of the hot body at a after time t is completed. So that means we need to assume that the initial temperature of the hot body some value at a final temperature of the hot body after time is equal to some value. Let me take for this one, let the initial temperature of the hot hot body is equal to T1, that is equal to where initial temperature means at T is equal to 0 time. So the final temperature of the body, final temperature of the hot body, final temperature of the hot body is equal to final temperature of the hot body is equal to, let me take a T. So what is the time we are taking? The time is equal to T is equal to T we are taking. Now we need to do the to find out the value of the T value. We need to do the perfect integration with the suitable limits, then only we can solve the problem. What is the, we assume that what is the formula we are having? Minus dt by dt is equal to k into t minus t naught, we are having the formula. Now send this negative sign this side, that is equal to dt by dt is equal to minus k into t minus t naught. Now send the, it is the time, it is the temperature parameters, then send the temperature parameter to the left side, it is the time parameter, send to the time parameter to the right side. So then dt divided by t minus t naught is equal to minus k into dt. So to get the temperature of the hot body at a given instant, after time completed T value, then how to do means we need to do the integration of this equation with suitable limits. Here is the we are doing the integration with temperature of the hot body. What is the initial temperature of the body? It is the T1. What is the final temperature of the hot body, which is a time? It is the T value. What is the initial time of the observation of the experiment? It is the T is equal to 0. What is the final time we experiment is completed? That is equal to T. If you do this integration, you can easily solve the you can easily get the equation. Will you please look on, you already well familiar about integration of 1 by x dx is equal to log x formula. You already know integral of x power 0, that is equal to nothing is there, 1 into dx is equal to x value we will get. Here is the negative k is the constant term, you can take it outside that one. This formula can be written as integral of minus t is equal to 0 to t is equal to t into dt. Then we concentrate on the left side integration. What is the formula we are having? 1 by some x value into dt is there, that is equal to log x you will get. So log x means log of t minus t naught. We need to apply the limits. The lower limit is the t1, upper limit is the t. So that is equal to, here is the negative k is there, nothing is there means 1 is there, 1 into dt. We are integrating this equation with respect to time. You will get the time into lower limit is the 0, upper limit is the t. Now this t naught is the constant parameter, that is the temperature of the hot body. This upper limit and lower limit must be applied the variable value, that variable value is the temperature of the hot body. So these values must be applied on the temperature of the hot body, this upper limit and lower limit. First of all I am applying, let me go to the apply the high upper limit of the upper limit value temperature. Log of upper limit I am applying t minus t naught minus lower limit log of where the lower limit is applying, that is equal to t1 minus t naught is equal to, in this equation also we are going to apply minus k into t minus 0. This is the formula we are getting. So t minus 0 means 0, you can no need about this one, minus kt, you will get the formula like this. So will you please look on this one, log of t minus t naught is equal to this value I am sending to the right side, that is equal to log of t1 minus t naught minus kt. This is the formula we are getting. Again think, please concentrated about this equation. See, this is the t, time is a variable, so this is the variable means t, k is the constant, this is the variable means this variable I am taking x, this constant I am taking as a m. So this is a T1, it is the initial temperature of the hot body, it will have some value, it is a constant value. T naught is the surrounding temperature of the surrounding temperature, it is also constant value, this total value is some constant, then log of some constant you will get some constant, that is equal to C. Again this formula is equal to, here is the T naught is the surrounding temperature, T is the temperature of the hot body after time t. So this is the variable, so this is the variable, means that complete will get the variable value you will get. So that means variable is equal to, I am taking that variable is equal to y. So that formula we are indicating that y is equal to mx plus c formula we are getting. But please concentrate here, m is the slope of the graph, that slope is indicating that negative slope here. Negative slope means how it look like the graph. If you draw a graph between the y value is equal to log of t minus t naught value. So in the x value is equal to, what is the time we are taking, x value, t is equal to time in the x value. So it is indicating that negative slope means this value will get the this of this graph shape we will observe. So what is the slope of this graph? The slope of this graph is equal to k value, they will give the information of this k value. Now let me go to the another continuation concept, another board. So will you please, what is the previous formula we are getting? Log of t minus t naught is equal to log of t1 minus t naught, t1 minus t naught minus kt formula we got in last equation. Again I am sending this equation to left side, log of t minus t naught minus log of t1 minus t naught is equal to minus kt we are getting. So you already well familiar of the formula, log of a minus log of b is equal to log of a by b. This is the formula we already known, this formula is known. Here is the log of a, this formula is, this value is the a, this value is the b, then log of t minus t naught divided by t1 minus t naught is equal to minus kt. You already know this value of log of a is equal to log of x is equal to some a value is equal to, then x is equal to e power a. This formula you already known, I hope. So with help of this one, what is this value? T minus t naught divided by t1 minus t naught is equal to e power minus kt, because of here is the, this value is the a and we are assuming this value is equal to x. Now from this equation, what is the value we can write? T minus t naught is equal to t minus t naught is equal to t1 minus t naught into e power minus kt. So again I am sending t naught to other side, then t is equal to t naught plus t1 minus t naught into e power minus kt. This is the formula. That is we attain, that is what is our goal of this concept. That means the temperature of the hot body after given instant time, after time completed t time, the temperature of the hot body capital T is equal to t naught plus t1 minus t naught into e power minus kt. This is the formula what we need to what we will get final formula in the Newton law of cooling. Again we need to concentrate some of the concentrate here. Let assume if time is equal to 0, that means what is the at initial time, at initial time, what is having about this at initial time, what happened about this equation? Please concentrate on this one. T is equal to t naught plus t1 minus t naught into e power minus k is equal to 0. E power 0 is equal to 1, so this value is going to be 1, this value is going to be 1, then 1 into some value is equal to this value only, t naught plus t1 minus t naught. So plus t naught and minus t naught both are cancelled, that is equal to t is equal to t1. So what does that means? The temperature of the hot body at initial time is equal to, that is the T1, that is the initial temperature of the body. again it is the at t is equal to 0 time. So again I am taking what is the temperature of the body at a long time. Long time means we are taking at infinite of time. That means the time is a long time, long duration we waited to cool the hot body. That means if time is equal to infinity, time is the infinity time is I am taking, that is the at infinity time what is the temperature of the final temperature of the hot body. So the final temperature of the body, the final temperature of the hot body, final temperature of the hot body, what is happening about the hot body. So that means substitute this above equation, this equation I am going to substitute. So that is equal to t into t naught, t is equal to t naught plus t minus t naught into e power minus k into infinity. So e power negative infinity is equal to, that value is going to be 0. So that value, this value is going to be 0, this value, this 0 into multiplication, some value is equal to 0, then t is equal to t naught. What does it mean? So the at infinity, the at a time infinity time, the body is going to be attained, the temperature of the hot body is going to be attained as equal temperature of the surrounding temperature. That information it is going to give. So now if you draw a graph, with respect to the time and temperature of the hot body at each and every time, then what will happen, if you already known this one, at initial time t is equal to 0, what is the temperature of the hot body it is having as a T1 temperature it is having. What is the at a temperature, it is the t is equal to infinity time, it is the infinity, what is the temperature of the hot body is equal to, it is having the surrounding temperature T naught. So what is the in between, what is the position of this graph, what is the shape of the graph? Will you please look on this one? It is the constant term, it cannot be give the information of this of the graph. It is also constant term, it cannot give the information of the graph, but because of t minus t naught, initial temperature and surrounding temperature is the constant term. Here only we are having the exponential time is there. This graph is giving the information of the shape of the graph. It is exponentially decreasing graph. Then from initial time to final time, the temperature of the hot body is going to be exponentially decreasing. That is the exponentially decreasing graph, like the shape it is going. So from this graph we can get the conclusion, some of the conclusions. That what does that mean? Conclusions means at initial time the rate of cooling is more. So that me take at initial time the rate of cooling is very more, it is the temperature is so for small duration of the temperature only it is decreasing more temperature. At final time, let me go to the, if the temperature is increasing, the rate of cooling is very small, even we are taking the longer time also. Will you please look on this one? It is the time difference, delta T2. So but the temperature difference is very short. So that information is given. That is also the definition of this Newton law of cooling. That means the temperature of the hot body will decreases rapidly at initial time, and it will going to the very slowly at when the time is going on. So that is the very, very important of this equation. But one problem is there. Above equation. What is the above equation? We learn t is equal to t is equal to t naught plus t1 minus t naught into e power minus kt. This is the equation is there. But to solve the numerical problems, we are unable to use this equation because of it is the exponential term is there. We need to use the logarithmic equations. That's why they are not giving this direct formula in this equation. If they are giving that equation, that that answer also they will provide it in the exponential term only. That is a very easy problem. Just we need to substitute what they given, that information data we need to substitute in this equation. But how to solve the numerical problems means to solve the numerical problem, Newton is given to the another approach. What is that approach means? The average rate of cooling is so let me take that formula. The average rate of cooling, the average rate of cooling of hot body is the directly is equal to negative of K into average temperature difference, average temperature difference of the hot body to surrounding. So is the negative sign of average temperature difference of hot body to surroundings. So this is the formula, this is the concept which we need to use in the solve the numerical problem. For this one we need to assume that this is the hot body is there, the initial temperature of the hot body, let me take T1. So this after time passes, if a time passes, that is equal to T is equal to the time T is equal to, it is the time is taken T, the hot body temperature is going to the another temperature T2. This hot body is in the surrounding temperature of this T0 surrounding temperature is there. That means what is the average rate of cooling of the hot body? Average rate of cooling of the hot body is equal to average rate of cooling of hot body. Hot body is equal to, that value is equal to, so T1 plus T2, T1 minus T2, T1 minus T2 divided by T, this is the average rate of cooling of the hot body. So what is the average temperature difference of the hot body to surrounding? Average temperature difference of hot body to surroundings is equal to, what does that means? So the average rate of the average temperature difference of the hot body, that is equal to T1 plus T2 divided by 2. It is the average temperature of the hot body, my difference to surrounding temperature T0. That means they are taking this negative K also I am taking, that is equal to T1 minus T2 divided by T is equal to minus K into T1 plus T2 divided by 2 minus T0. Now will you please concentrate this one, I am sending this negative sign to this side, that is equal to T2 minus T1. Average rate of cooling means what is the temperature difference, final temperature of the body and initial temperature of body. So sorry, please correct this one, T2 minus T1. So T2 minus T1, that is equal to, if we send this negative sign this side, that is equal to T1 minus T2 divided by T. That is equal to K into T1 plus T2 divided by 2 minus T0. Average rate of cooling means how, final temperature minus initial temperature, this is the final temperature, this is the initial temperature, that is the formula we need to use. Now let me go to the let me use this formula once again I am writing what is the final formula we concluded. So T1 minus T2 divided by T1 minus T2 divided by time t is equal to T1 plus T2 divided by 2 minus T naught. This is the formula we are having. So with help of this formula we can easily solve the numerical problems what they given. So let me go to the JEE problem. What they given, JEE means problem in 2020 they are giving problem. We will solve the problem. You can easily understand how we are going to apply this one. What the problem they given means, a metallic sphere cools from 50 degrees centigrade to 40 degrees centigrade in 300 seconds. If atmosphere temperature around is 20 degrees centigrade, then the sphere's temperature after the next 5 minutes is a question mark. Options also they are provided. So what is the option A is equal to 31 degrees centigrade, option B is equal to 33 degrees centigrade, option C is equal to 28 degrees centigrade, option D is equal to 35 degree centigrade. This is the formula. Now use this above concept about this equation, what they are providing. So they are taking that let me take, this is the hot body. What is the initial temperature of the hot body? Hot body is having at initial temperature is equal to that T1 value is equal to 50 degrees centigrade. So what is the temperature, final temperature it is attained? So it is attained T2 is equal to 40 degrees centigrade. In how much time it is attained in this one? The time is equal to 300 seconds. 300 seconds is nothing but if you divide with, here is taken the minutes and here is the second what that is your time. So 300 second is gain. So apply this sequence, here is the K term is there, I missed that one. So apply, use this formula in this given first observation. So that is equal to T1 minus T naught. Now just I am applying this formula, T1 minus T naught. So that is equal to 50 minus 40 divided by how much time we are taking, 300 is equal to K into T1 minus T naught is equal to, that is T1 plus T naught is equal to 50 plus 40 divided by how much, so 2 minus what is the temperature of the surrounding, 20. This is the formula we are getting. Now again the same, after 5 minutes they are asking, after 5 minutes so what is the initial position of the body? The body is having at a temperature is equal to T1 is equal to 40 degrees centigrade. So it will attain another temperature, T is equal to question mark. The time is equal to taken, T is equal to 5 minutes. 5 minutes means how much? 5 into 60 is equal to 300 seconds. Now again apply the same formula in this above equation. So will you please let me take this the equation 1. Now again I am applying this second observation. What is the observation we are having? T1, so this formula T1 minus T2, here is the T1 is equal to 40 degrees centigrade, 40 minus T final temperature T divided by how much time we are taking, 300 seconds, that is equal to K into that is equal to K into, let me take that one, sorry, so K into 50, here is the initial temperature is equal to T plus final temperature is equal, sorry, initial temperature is equal to 40 plus final temperature is equal to T divided by 2 minus 20. Surrounding temperature we are unable to vary. This is equation number 2. Now you can solve this problem as a shortcut method, or you can go through that solve the k value. The k value must be substituted in this second equation. So that is the long process. So to solve the problem directly, do the 1 by 2 or divide the first equation with equation to second equation. So now I am doing 1 divided by 2. 1 divided by 2 means what is the first equation it is saying? Sorry. So 50 minus 40 is equal to 10. 10 divided by 300 we are getting. First equation it is showing. So 10 divided by 300, it is the first equation left side. So what about the so the 10 divided by, what is the left side of this second equation? 40 minus t divided by 300 we are getting. So 40 minus t divided by 300 we are getting, that is equal to, right side I am taking. So sorry, right side k divided by 50 minus 50 plus 40 is equal to 90. 90 divided by 2 is equal to 90 divided by 2 is equal to 45. 45 minus 20 is equal to, this is the 45. 45 minus 20 is equal to 25. So this is the 25 value. So 25, k into 25. So k into 25 divided by now down one, k into 40 plus t divided by 20 into, we are unable to do this one. So so k into 40 plus t divided by 2 minus minus 20, this is the formula we are having. So here is the k and k both will cancel, 300 and 300 both will cancel. So then 10 divided by 40 minus t is equal to 25 divided by 40 plus t divided by 2 minus 20. This is the formula we are getting. So again will you please concentrate here, 5 2 jar 5 5 jar 25. This is the formula we are having. Do the cross multiplication and do the cross multiplication. So that is equal to 2 into 40 plus t divided by 2 minus 20 is equal to 20 is equal to 40 minus t. This is the formula we are having. So again we will send this to this side, send this to this side, that is equal to 40 plus t divided by 2 minus 20 is equal to 40 minus t divided by 2. This is the formula we are having. So bring this equation to this side, what will happen? So that is equal to 40 divided by 2. So I am writing separately this one, plus t divided by 2. Again I am sending this this value to this side, means minus of 40 divided by 2. So this minus of minus, it will become plus t by 2, plus t by 2 is equal to minus 20 is equal to 0. So plus 40 divided by 2 minus 40 divided by 2 is equal to t by 2, t by 2 is equal to t. Somewhere I did mistake. Yes, here we are having the 5. So we missed that 5, sorry. So let me, so we missed that 5, so that's why we are getting wrong approach. So let me go to the, this 5 is, I missed this 5. So do this 5 also here. Let me go to the, here, yes, here 5 is there. So that means what will happen now? Do this one, what will happen? So normal multiplication I am doing. So 40 plus t into this 2 and this 2 will cancel, that is equal to minus 2 into 2 is equal to 40, that is equal to 5 into 40 is equal to 5 into 40 is equal to 200 minus 5t we are getting. So Again send this 52 to this side, plus 40 and minus 40 is cancelled, so send this 500 to this side, so that is equal to 60 is equal to 200, 60 is equal to 200 because of 5t is going to this side. So we are having 60 is equal to 200, then t is equal to 200 divided by 6. So 600 means 6 3s are 18, so 18 is equal to 3, 2 will remainder, 6 3s are again 18, 2 will remainder, 6 3s are 18, again 3 is equal to remainder, 33.33 we are getting. So the temperature we are doing the Celsius means that 33.33 is the correct answer. Now let me check this, what is the problem they are giving. So let me check the problem what they provided. This is the problem. So this is the problem. So what they are given, a metallic sphere cools from 50 degrees centigrade to 40 degrees centigrade. What is the correct answer? So correct answer is the near value is equal to 33.33 degrees Celsius. So the near value is equal to 33 degree Celsius. Because with the help of the rounding rule, we can easily eliminate the so the numbers which is having less than 5, that is equal to 33.5 degrees centigrade. This is the correct approach to solve the problems. So I hope I given good information for you to solve the problems on the regarding the Newton law of cooling. So thank you for watching. If you want to some concept on any topic, you can post on our on comment section. I will try to explain on that important topic. Thank you.